Okay, let's look at the second part of the problems in slide 52. I have written these out, but I am going to write the answer. For this one, we'll do it a little differently. But let's look at G. 28.7 minus 0.0483 gives us 28.65. Now, because I'm subtracting, I need to look at the numbers after the decimal point. 28.7 has 1, 0.0483 has 4, which means that my answer can only have one digit after its decimal point. So I have to cut it off right here. Now, because this is a 5, I need to round up, so 28.7. I have one digit after my decimal place as this one. Okay, now for this one, I have a mixed operations. I have subtraction here, but I have division here. However, I'm told to do the subtraction first, so I have to look what's inside the parentheses. Now, if you do that, you will get, and I'm not going to write it all out, you'll get a number, but we'll look at the number of decimal places after the number of digits after my decimal place. This has 1 and this has 2. So my answer can only have one digit after the decimal. And if you do that, you should get 0.9 as your answer. And if you divide that by 45.13, that should give you an answer of about 0.026 or 0.061. Okay? But now, because I'm dividing, I look at the total number of significant digits. This has 1 and this has 4, which means that my answer can only have 1. I have to cut it off here, which means that this is equal to 0.02. Let's look at this number. This is a multiplication, so my answer should have the same number of significant figures as the one that has the least. These have the same amount, they're both 3. So if you do that, it should come out to 214,776. However, because there's 3 significant digits for each, my answer can only have 3 significant digits. So these have to become zeros. And because this is a 7, this will become a 5. So the number will then be 215,000. Or I can also write it as 2.15 times 10 to the 1, 2, 3, 4, 5 to the 5th power. And I have 3 significant digits here because both of these numbers have 3 significant digits. Now let's look at this operation. It doesn't matter, you're not adding, subtracting, or multiplying and dividing. It's all multiplication. But for this one, I have 3 significant digits here and only 2 here, which means that my answer in general will be limited by this number because this has only 2 significant digits. If you do this should give you 574 because I'm stopping at 3 significant digits. And this will be 760 because I'm stopping at 2 significant digits. And if you multiply these two numbers together, you will get 436,240. Now, because I'm limited to 2 significant digits, I will approximate that as 4.36 times 10 to the and I said 2 significant digits, and I wrote 3. So I will write this as 4.4 times 10 to the 1, 2, 3, 4, 5 to the 5th. This 6, because it was a 6, I rounded it to 4, and therefore 2 significant digits because this number, my original number here, had only 2 significant digits. Let's look at this division. Once again, it's a division. So we will look at the number that has the least amount of significant digits. If you do that, it will give you 2.0767. However, when we look to see how many digits it should have, this has 3, and this has 4, so my answer should only have 3. I will have to cut it off here. Because this is a 6, that will become an 8, so 2.08 is my answer for that. Okay, and then the last problem, it's also multiplication, so I look at the number that has the least amount of significant digits. If you do this calculation, you should get 0.1867. And let's look at the significant digits. This has 4. This is only 2. All of these zeros are not significant because they're just placeholders, which means that my answer should only have 2 significant digits. I have to cut off here. Because this is a 6, I will have to make that a 9. So 0.19 is the answer to that, to L. Okay, this is the end of the problems on slide 52. I will erase these and then we'll move on to the problems on slide 53.